Okay, guys, if you're here, that means you got through 9-3. 9-3 is a really tough section, so congratulations. 9-4 isn't tougher. It should be easier, so that should give you a little bit of relief. This is the last way we're going to learn how to factor, and it is called a difference of squares. Okay, so remember that factoring flow chart we did? Well, we're going to add to it. So write it down again. What's the very first thing you should look for in any factoring problem? A GCF in all of the terms. Whether there's 2, 3, 4, 5, a million terms, you always look for the GCF in all of the terms. Then, after you've factored out, you need to ask yourself, how many terms are there? What is the number of terms that you have in your leftovers? If there are 4 terms or more, 4 plus, then you factor by grouping. And that's what you learned in section 9.2. If there are exactly 3 terms, then you do AC method, which is what you learned in 9.3. Keep it in mind you can take the shortcut if your A is 1. And then the final way we will learn is if there are 2 terms, you will see if it is a difference of squares. So I give you this because a lot of times students will say, well, I don't know which way to factor. Well, follow this through. Always start with the GCF, and then the way you will continue to factor depends on how many terms you have. Okay, so what is a difference of squares? Well, what's difference mean? Difference means subtraction, right? And squares are things, not the shape, but the things that have been squared. So some number squared. It's a difference of those, and we said we're going to use it when there's 2 terms, so you need to have 2 squares that are being subtracted. Something like this. Okay, so sometimes this is going to be a number, like 4. 4 is 2 squared, or like 9. 9 is 3 squared, or it's going to be a variable. Okay, so it could be either, or it could be both. If you have a difference of squares, then it will always factor into A plus B and A minus B. So what's A? Well, it's just the square root of whatever this one was. What's B? It's the square root of whatever B squared is. Let's try one. So go through your flow chart. Is there a GCF in all the terms? No, x squared and 4 have nothing in common. How many terms are there? There's 2 terms. So 2 terms, we look for a difference of squares. So 2 things you have to check for. I guess 3. First thing, is it a difference? You can only do it if that right there is a subtraction sign. It is, so that's good. Then, is this something squared? Sure. Is this something squared? Sure. So then it is a difference of squares. It's going to factor into 2 sets of parentheses. What goes first in each one is essentially just the square root of this. The square root of x squared is x. That goes first in each parenthesis. What goes last in each parenthesis is the square root of this. Ignore the minus sign, just the number or the term back here. The square root of 4 is 2. That goes in the back in each one. 1 with a plus sign and 1 with a minus sign. Technically, that order doesn't matter. You could put the minus and then the plus. I always do plus then minus. Okay, that's your answer. That's all there is to it. How would you check it? You'd multiply it out. X times x is x squared. X times negative 2, well, that'd be a negative 2x. But then what's 2 times x? That's positive 2x, and those cancel. That's why there's nothing in here. And then 2 times negative 2 is negative 4. So sure enough, that checks, that works out. Okay? Another one. Now, before you jump ahead and start trying to factor this as a difference of squares, rewind. What's the first thing you should be doing? Is there a GCF in both terms? Yeah, they're both divisible by 2. So if I take 2 out, I have m squared left here. And if I take it out of here, remember you're really doing division, so that would be 49. Now, just because I did one thing doesn't mean I'm done. You need to always continue to keep factoring until you cannot factor any further. Okay? So looking at what I still have in here, can I factor that? Well, there's two terms, so I need to check and see if it's a difference of squares. Is there a difference? Is it subtraction? Yes. Is the first thing something squared? Yes. Is the last thing something squared? Yes. So I can factor this into a difference of squares. I need to make sure I leave 2 in my answer. That needs brought down, that GCF. And then I have 2 sets of parentheses. So what do you square to get m squared? In other words, what's the square root of m squared? Well, that's m. That goes first. We know we have a plus and a minus. And then what's the square root of 49? Well, you got to square 7 to get 49. So there you go. If you wanted to check this, you want to multiply this all out. Sometimes students will think they have to do this, but that's not the way it works. Okay, you would only distribute it to the first parenthesis. So you'd have 2m plus 14, and then you'd have the m minus 7 by itself, then distribute again. Okay, so you don't want to take the 2 times 2 different things, just times the first set of parentheses. And sure enough, my middle 2 terms cancel, and I come back out with what I started with. Now, if you had this on your paper, I would take off for it, because it looks to me like your final answer is the bottom line, which is not your answer. Your answer was right here. So if you're going to check your work right in line, you need to make sure you circle your answer. Otherwise, just do that off as scratch work to the side. Okay, don't forget, always start with the GCF. Some of you guys, I told you in the last section, if you forget to start with the GCF, you need to do it at the end, because your final answer should have no common factors in your parentheses. So always try to start with it, but if you forget it, sometimes you can redeem yourself at the end. But the priority, the better way to do it, is to do it from the beginning. The GCF in both terms here is 2x. That leaves you with b squared minus 25. Pause the video, see if you can finish that. That was in fact a difference of squares, b and 5s. Okay, hopefully you got that right. Don't forget to include the 2x as part of your answer. Okay, GCF in all the terms? I don't see one. Is it a difference of squares? Well, it's definitely a difference. Is this something squared? Yeah, that's 9 squared. Is this something squared? Maybe you said, no, it's something to the 4th power. But could you square something and get something to the 4th power? For example, what's n squared squared? That's n to the 4th. So this is a difference of squares. Anytime you have an even exponent, you can write that as something squared. Say you had n to the 16th. You could make that n to the 8th squared. So anytime, because you remember you would just multiply these numbers. So anytime you have an even exponent, that can be something squared. So the square root of n to the 4th, or what do you square to get n to the 4th? You square n squared. Plus, minus, what do you square to get 81? Square root of 81 is 9. Okay, so don't be scared if you have a bigger exponent, it just has to be even. Now, you're not done. Remember what I said. When you think you're done, you need to look in your each factor, look at each one separately. So look at just this one first. Can you factor that further? There's no GCF. There's 2 terms. It's not a difference, so you can't do that one any further. Look at the second one. No GCF. There are 2 terms, but it is a difference, and both things are squares. So this one can be factored further. N squared plus 9 cannot be because it's a plus, but the one with the minus can be. What do you square to get n squared? N. And what's the square root of 9? 3. 1 with a plus, 1 with a minus. Ta-da! There's your answer. And you could still multiply all this out to check it. Just got to do some distributive property. Okay, What do you start with? GCF in all the terms. Do you have one? In all of them? No. How many terms are there? There's 4. Okay, so think about it. How do you do it with 4? You factor by grouping. The GCF in the first half is m squared. That will leave you with m plus 2. The GCF in the back half is negative 81. That leaves you with m, and be careful here, you pull the negative out, so now it's a plus 2. Thankfully, our parentheses match, so we can factor those out. And what's left is m squared minus 81. Before you put your pencil down and keep moving forward, you need to check your answer. And I don't mean check it by multiplying it. I mean check it and make sure you can't factor further. This is not a difference. There's only 2 terms, no GCF, so you cannot do that. But the second one, 2 terms, no GCF, then 2 terms is the way you should think of that. And it is a difference, and it is squares. Okay, so you always need to be looking to see, can you factor any further? This one can be. M times m would give me the m squared, plus and a minus, and 9 times 9 would give you the 81. Then if you check again, there's nothing further to do. Maybe you're like, oh wait, here's a difference of squares, but this m is not squared, so you can't do that any further. All right, I'm going to have you try the last 2 on your own. So pause the video and try these 2. Okay, check out my answer for number 6. I started by finding the GCF in both terms, factored it out, and then what was left, I had a difference of squares, so then I factored that. Now, I bet you some of you did this, that you took that problem and immediately factored it as a difference of squares. Because the way it's written, this is a difference, this is a square, and that's a square. So you may have just done this. The problem with doing that, you still have a GCF in this group and a GCF in this group. Out of this group, you would need to pull out a 5. Then you'd be left with 2s and plus t. Okay, but then in this group, you also have a 5, so you'd have to pull that out as well, and you'd be left with 2s minus t. Well, we don't leave things like this. This number would have to come out to the front. So 5 times 5, and order of operations doesn't matter because it's multiplication. And multiplication, you can switch the order. So 5 times 5 would be 25. And then these, which is the same thing I got up here. Okay, now this one works out that we forgot the GCF in the beginning, and we were able to do it at the end. It won't always work that way. You should definitely look for that, but sometimes you'll get stuck and not see it because you're not pulling the GCF out at the beginning. So I don't know how many times you need to hear this, but hear me say it again. The very first thing you should do on any factoring problem is pull out a GCF, if there is one. Always look for a GCF first. Okay, and then the last one, GCF, there it is, it's a 3. And then can you factor this further? Yes, because remember, even though that's a 4, that is really k squared squared. So that is a square. And I hope you didn't stop there, because this one is another difference of squares, and you had to do it again. That's your final answer. Now, some students will say, okay, but when I did this and stopped there and checked my answer, it worked out. But remember, that's only a partial check. That just tells you that this and this are still equal. It doesn't tell you that you have completely factored the problem. Same way as if you would have checked this answer, this is the same as the original, but it's not completely factored. So you're not completely done until you get all the way down to there. Okay? All right, get moving on that packet.